And the method of proving that I'm going to follow is that you first factorize it, this quantity in the argument of the logarithm. Let us first factorize that. To factorize it, you set it to 0 and find solution. So solve 1 plus 4 over a x into 1 minus x equal to 0. So that is 4 by a x square. And the solution of this quadratic equation is x equals minus b plus minus square root of b square 16 by a square minus 4ac 16 by a divided by 2 times a 4 by a. And upon simplification, this will be given by half 1 plus minus square root of 1 plus a. Therefore, the original expression 4 by a x times 1 minus x is equal to x plus a times b minus x, where a is equal to half square root of 1 plus a minus 1 and b is half square root of 1 plus a plus 1. Now, factorization. Okay, so what we have done so far is the a and b are the roots of this being equal to 0 equation. So this expression will be equal to 0. So if you multiply this by an overall factor, some overall factor, say c, then also this will be satisfied. What it guarantees, whatever I have written here, what it guarantees is that if this is equal to 0, then this must also be equal to 0, because a and b are the roots of this equal to 0 equation. But that does not fix the overall constant c. To fix the overall constant c, you have to, the one way to find that overall constant is to compare the coefficient of x square. So coefficient of x square on right hand side is -1. Here the coefficient of x square is -4 by a. So I should multiply by 4 by a. Then that is how you fix the overall constant. So then we wanted to calculate this integral dx 0 to 1 logarithm of this. So integral dx 0 to 1 log of 1 plus 4 by a x 1 minus x is given by integral dx 0 to 1 log x plus a times b minus x plus log 4 by a. Okay. And that is same as dx 0 to 1 log x plus a and this is same as integral dy log y from a to 1 plus a, and this is same as dy log y. Now y is, in this case, y is x plus a. Here y is x b minus x, so dx is minus dy, and that minus sign can be absorbed by switching the limits. So when x equal to 0, when x equal to 0, y is b. So let's put b upstairs, and when x equal to 1, y is b minus 1. Okay, plus log 4 minus a. I just calculate this according to the limits, and you can do a simple algebra and show that you can simplify it and write it as minus 2 plus a log a plus 1 over a plus log a plus 1 plus b log b by b minus 1 plus log b minus 1 plus log 4 by a. Now you substitute the values of a and b and show that it's a bit of an algebra after substituting the values of a and b as given here. It's a bit of an algebra to get to the final result, which is given by this, but it is straightforward nonetheless. So let me okay. So so we have computed the fish also. We have computed tadpole and then fish, and now let's calculate the two loop, which is double scoop. Again, the incoming momentum, outgoing momentum, both are p, and the loop, the propagators within the loop are independent of that p. They are as marked by the values of the momentum. So this has two. So there's a symmetry factor both for this one and for this one, and that gives you a factor of 1/4. There are two vertices, so lambda mu to the power epsilon square, and then the loop integral dd L1 by 2 pi to the power d, and then dd L2 over. We have only one propagator for L2, but two propagators for L1. So L2 square plus m square times L1 square plus m square whole square. Now these two integrals, L1 and L2 integrals, are independent, so they will just I can just factorize them. So I can just write them as dd L1 by 2 pi to the power d 1/L1 square plus m square whole square times dd L2. So these are basically the I1 for different values of A. This is I1 for different, in one case A is 2, in the other case A is 1. So we can just straight away write the result. So for I1 with A equal to 2, which is m squared to the power d by 2 minus 2 divided by 4 pi to the power d by 2 gamma 2 minus d by 2 divided by gamma 2 times the other one, which is for A equal to 1, d by 2 minus 1, and yeah, so this will be m square to the power d by 2 minus 1 4 pi. Then you write d equals 4 minus epsilon, and the result you get is this. Yeah, okay. Mu to the power 2 epsilon times m to the power minus epsilon. So that is 1 over 4 lambda square m square mu to the power 2 epsilon m to the power minus 2 epsilon over 4 pi to the power. This prefactor of these gamma functions can be reorganized to write 4 times 4 pi to the power 4 lambda square m square 4 pi mu square over m square to the power epsilon gamma epsilon by 2 gamma minus 1 plus epsilon by 2. This is same as lambda square m square over 1024 pi to the power 4 times 1 plus epsilon log 4 pi mu square by m square. So, since we have two gamma functions, each having, we will have a pole, therefore the power of negative power of epsilon will be 2, and in order to get an order 1 result, we have to expand this one up to epsilon square, which is why I have done that in this case. So the first gamma epsilon by 2 will be expanded as 2 over epsilon plus psi 1 plus epsilon by 4. Since the gamma, each gamma is multiplied with another gamma, and this has a 1 over epsilon term, I should expand it up to order epsilon. Earlier, we did not have that. Earlier, we had only one source of 1 over epsilon. Now we have two sources of 1 over epsilon. So each of them will have to be expanded up to order epsilon, because 1 over epsilon in this will be multiplied with epsilon to give a order 1 term. Therefore, this gamma function has to be expanded up to order epsilon, and similarly the same argument applies to this gamma factor. So I have expanded up to order epsilon the first gamma factor, and then the second gamma factor will be given by -1 times 2 over epsilon plus psi 2 plus epsilon by 4 pi square by 3 plus psi 2 square minus psi 2 prime. So let me now write down let me finish this calculation on this side. So I have to just expand this products. So minus lambda square m square over 1024 pi to the power 4 minus lambda square m square over 1024 pi to the power. Then what is the epsilon to the power -2 term? That is 1 multiplied by these 2. So that is 4 by epsilon square. Then let's next look at 1 over epsilon terms. One over epsilon will be obtained by multiplying 1 over epsilon, and order 1. So that is 2 times psi of 2. Another term will be 1, this one, order 1, and 1 over epsilon. That is 2 times psi 1. So 2 times psi 1 plus psi 2. Let's see any other 1 over epsilon contribution. So this is how you can get 1 over epsilon starting from 1. Let's now start from this term. If it is order epsilon, then we have to choose 1 over epsilon square. So that is this one and this one. So that is 2 times to 4 times this logarithm. So we have 1 over epsilon square and 1 over epsilon terms. Now let's calculate order 1 term. So order 1 term will be, again, we start out with 1. 1 must be multiplied with this order 1 terms. That is psi 1 times psi 2. Then if you start out with epsilon, then it must be multiplied with 1 over epsilon here and order 1 here. So logarithm must be multiplied with 2 times psi 2. Similarly, you can choose this one, order 1 here, and 1 over epsilon here. So that is 2 times psi 1. So 2 times psi 1 plus psi 2 times this logarithm. 2 times psi 1 plus psi 2 times the logarithm. What else? Okay, so when I considered multiplying 1, I took 1 psi 1 psi 2, but there is another source of terms, 1 multiply order epsilon and 1 over epsilon from here. So that will be 2 by 4, which is half times this factor. Similarly, 1 multiplying 1 over epsilon from here and epsilon from here. So that will be again 2 by 4 is half times this. So half times this plus half times this. This is something that I missed earlier before. So plus half times okay. This was some term that I missed when calculating terms that are originating from this. Then we had calculated this, then last term to calculate this one, this is last term to calculate is this one. So that is epsilon squared. So I must uniquely choose 1 over epsilon and 1 over from both these two factors. And that will be 4 by 2, that is 2 times log square. So this is order 1 term and then order epsilon, which we neglect. This can be written in a slightly, I mean, you can slightly more organized way, you may say. Okay, so that is the result for scoop, double scoop. So I have used these two slides.